hidden camera. It'll be right in front of your face.
It'd be illegal if you put it online.
Alright, this is the fundamental theorem of calculus. But then they'd make another one. There's number 2 also, so that's weird to me. Like, if there's going to be a fundamental theorem, it should be like... This should be the... Yeah. What?
So are we doing number 1 and number 2 in this class?
No.
Number 2, like...
Just number 1.
Okay.
I would have made the title number 1 and number 2. Is that what you're asking about?
No, I was asking for
She means like period.
later in this year.
Yeah, we're doing number 2 in like a few days. Yeah.
Oh, okay.
Okay, sorry. I thought you said today.
I meant like in this course, or do I have to wait until I don't know?
In this course, yes. In this class period, no.
Okay.
Alright. So, let's make a little sketch of some random graph. Our endpoints are A and B. I'm going to call this graph f of x. And what I'm interested in finding is the shaded area between the graph and the x-axis. So you can imagine f of x is like meters per second. We're trying to find meters. Or its acceleration. We're trying to find velocity. So to find that, you integrate f of x from A to B. When you integrate, this is a weird like notational thing in calculus. When you integrate little f, the way they notate that is to say now you have capital F. So the integral of little f is capital F. If you have capital F and you take the derivative, they call that little f. So integrating little f of x gives us capital F of x. Put these little brackets around here and put A to B there. It's really easy when I show you examples. It's just goofy that it's lowercase, uppercase. Then, you plug B into your new, like the thing that you have integrated. So you're going to go capital F of B minus capital F of A. And that equals the area between curve and x-axis. There it is. That's the fundamental thing. So you guys should be good now, I think.
When Mr. Rodriguez was explaining this to me, he made me sit and listen to him while he was explaining this. It's like doing like initial and final, and then when you subtract them, it's like B is like the final.
B is the final, A is the initial.
Yeah.
So you do a final minus initial to find out like what's going on in the middle. Yeah? Yeah. Alright. So, these can be pretty straightforward, which is what we're going to start with, obviously. Where it's just like, here, go through this process, get a number, get your answer. But they're more interesting when they start giving you different pieces. So they might give you, they could actually give you like f of b and this, and ask you to find f of a. And look at it. Let's just look at like how to do basic. So let's say y equals x squared. Just an easy one to start with. We're going from 1 to 3. I want to find that area. So we can do it with rectangles, but that's not very accurate. Unless we start getting more and more rectangles, then it's a pain. But if we let the number of rectangles go to infinity, that's what an integral is. So we're going to integrate from 1 to 3. X squared times dx. That is going to equal 1/3 x to the third. That needs to be evaluated at 1 and 3. The plus c will actually cancel out, which I'll show you why in a second. You might be like, why is there no plus c? I'll show you why in a second. It's not necessary. Then you plug in the top number minus, plug in the bottom number, and so you can maybe tell right now why the c goes away. Because if I put a plus c there, and I plugged in the 3, I'd have a plus C like in this spot, right? But then I'd be subtracting a plus C that's over here also, so those plus C's would just kind of end up going away. So I mean, I guess you could write them if you really want to, but they just cancel. And then figure out what this is, and that'll be that area. So 3 cubed is 27. 1/3 of that is 9. So 9 minus 1/3 would be 8 2/3, or 26 thirds. And that represents the size of that shaded area. Yeah.
Do you know which number? Do you put the number that's furthest to the right on top?
Furthest to the right on top. Yeah, so this is your, okay, so A is your left-hand boundary. B is your right-hand boundary. Is that what you're asking? So you might want to go back up here. And then what happens is, if we flip those, what do you think would happen to your answer? If instead of reading from left to right, like I typically would, I read from right to left, what do you think would happen to the answer? It would just be negative. So if I did this integral from 3 to 1, all of a sudden it wouldn't be 9 minus 1/3 anymore, it would be 1/3 minus 9, which would just make it a negative answer.
But then, if you get a negative answer, doesn't the area have to be positive?
So negative, you can have a negative area. It means it's below the axis. So it's like the number is the area. Like if it was negative 9, that means there's a size of 9 and it's below the axis. Yeah. So you're right, area can be negative, but kind of the way we're looking at it. Yeah.
So what if the original problem had like x squared plus 5? Wouldn't that, the integral would be the exact same, but the graph would...
The integral would be the same. It would be 5x. It would be 1/3 x² plus 5x.
Oh, done. I was thinking through it.
Okay. You might have been asking what you were asking. I'm not
Yeah,
sure.
I think he was trying to...
Yeah, so you might be saying, like, how do I know if it's 1/3 x³ plus 5?
Yeah,
For
what
the
if
integral?
it plus c...
And we don't know what the c is.
Yeah, what if that screwed off my answer?
So you default, and unless you're told otherwise, c is 0. And there will be situations where they're like, so they could say, for example, the derivative is x². F of 2 equals 7. And then you can use that information to find out what c actually is. But if they don't give you this, you just default and like, okay, there's no c. Or c is 0. Does that help you?
Yeah.
That's what you're asking,
Yeah,
right? Okay.
that's what
Yeah. Were you going to ask something else, or you were just pointing out that that's what he was asking? Yeah. Other questions on that one? So there's a ton to get into with this. But we're just starting with the basic, like, can you do the process? So let's say this is x to the 3rd. We're going to look from -2 to 1. At the end of this, should my answer be positive or negative? Negative. Why, Bob? So, like, below the x-axis, we're going all the way over to 2. Above the x-axis, we're just going to 1. So these two, I got shading everywhere, I know, but can you see how these two little pieces would just kind of cancel out? And then whatever this negative is would be your answer, basically. So let's go through one where we got some negatives involved. So we're going to integrate from -2 to 1, x to the 3rd times dx. If I integrate from -1 to 1, what would the answer be? It'd be 0. We could verify that, but we don't need to. But -2 to 1. Do you guys want me to do it, or do you want to try it? Try it out. So integrate your x to the third. So give you 1/4 x to the fourth. Still got your 1 and your -2 there. Remember, this is the left hand, this is the right hand. Then you plug it in the top number, minus, plug it in the bottom number. So you just work through it. So that'll be 1/4 minus 4, which is like 1/4 minus 16/4, which is -15/4. But to be honest, so on a multiple choice, you have to do that. But on free response, you can leave it like that. Actually, on a free response, you can leave it like that.
Really?
Yeah. Just typing that into your calculator will give you the same thing as the answer. At that point, they're like, don't waste your time. Simplify. Just do smarter things. How many had -15/4? Questions? So let's do one with 2 terms. It just makes it a little bit tougher to keep track of your positive and negative signs.
Are you saying like plus something?
Yeah, so this is y equals the square root of x plus 1. The plus 1 is not underneath the square root. And we're going to look between 0 and 4. Find that area. So the biggest suggestion I can make is to use these big brackets. So plug into your first one, lock that number into a giant bracket, minus, plug into your second one, lock that number into a giant bracket, and then subtract. If you try to distribute the negative, it'll work, there's just more chances to screw up that way, I think. There's plenty of chances to screw up. I try to reduce those whenever I can. So you're going to integrate from 0 to 4. I'll probably make that x to the 1/2 times dx. So your integral would be 2/3 x to the 3/2 plus x. You got your 0 and your 4. So what I'm saying is I always do this. Like just one giant bracket minus another giant bracket. I work out all the way in there, and then the this is going to be 2/3 times 4 to the 3/2 plus 4. This one's nice, and this doesn't happen every time it's a 0. But in this one, what do you subtract? It just goes away. But if it was, for example, like the square root of x plus 1, if you plug a 0 into that, it wouldn't go away, right? So just don't always think like, oh, it's a 0, it's going to go away, because that's not necessarily true. In this one, it does. Usually it does, but not always. So this is just gone. All right, I got this root power thing that you guys are so fond of. Second root of 4, 2 to the 3rd, 8, and then that'd be 16/3 plus 4, and 4 is 12/3. So I would write that as 28/3, or stop there, or heck, stop there. But on multiple choice, the answer is going to be 28/3, so you're not really going to be able to stop there on that. But how many had 28/3? Somebody feel like you got the process? You're good? Questions I can help with? So then, when you think about what's coming next, we started regular or indefinite integrals, which is kind of basic stuff, right? Now we did U substitution. So these with U substitution are what's coming next.
Oh.
Like where you have to plug in.
That just sounds like, yeah. It's probably not scary because integrals are really easy. Well, they tend to be. They're easier than derivatives. They don't have a billion steps. But it just sounds scary.
Yeah.
No, you know how to integrate everything that you're ever going to know how to. Well, in this life, in your future life, I don't know what you're going to.
You get a PhD in mathematics.
Yeah. It'd be awesome.
They get a bachelor's.
He could be smarter than Mr. Davis.
I don't know.
Life goals.
He usually.
Whether or not he's smarter than me is determined already. Whether he gets a PhD or not. I think he's already smarter.
Say, well, assessors smarter than him.
Oh yeah, some of you.
I would not say that I'm